We'll start with full backups, as these are the easiest to understand. Full backups back up everything on a system, or everything defined in a backup job. So if you've got a backup job that says back up my C drive, a full backup will back up everything on your C drive. If you then run exactly the same backup job again in maybe an hour, it'll do exactly the same, back up everything on your C drive. Same goes if you run the job again, and again, and again. Now, let's imagine you're backing up your C drive, maybe to a tape library over the network, or maybe even to the cloud. Every time you run the job, you drag the entire contents of your C drive either over the network to the tape library or over the internet to the cloud. And if you've got a big old C drive loaded full of data, that's going to be a lot of backup data to shift over the network or up to the cloud. And it's probably quite a waste of bandwidth if all you've done is changed maybe 2 files on your C drive. But that's how full backups work. They back up everything defined in the job every time you run them. Fortunately, there are other types of backups. Next up is the differential backup. These babies are a little more complicated to understand, but they're not hard, so stick with me while we talk through this. We'll stick with assuming we're backing up our C drive. Before we take our first differential backup, we always start out with a full backup, as we show on the slide. This full backup backs up the entire contents of our C drive on day 1. Then, on day 2, only a small subset of our data has changed. We highlight the changed data in green on the slide, and what the differential backup does is only backs up that changed data. Then, on day 3, we change just another small subset of data. This time we highlight it as yellow. When the differential backup job comes along to back up our C drive on day 3, again it only backs up that changed data. The data that's changed since the previous differential backup. Again on day 4, we change another small amount of data, and the differential backup only backs up that changed data. Only the data that's changed since the last differential backup. Same goes for day 5. Just backing up the data that's changed since the differential backup on day 4. So, obviously each day, or each time we take a differential backup, we're pulling massively less data across the network and storing massively less data to our backup device than we would if we ran a full backup every time. But here's the but. Always a but. Differential backups are complicated and slow to restore from. Let's say that on day 5 our C drive failed and we lost its entire contents and we needed to restore it from the most recent backup. The problem is the most recent backup was on day 4 and all it contains is data that had changed since the backup on day 3. But that's not much good to us because we want everything restoring. The same goes for the backup from day 3. It only contains the data that had changed since day 2. Hopefully you get the picture. In order for us to recover the entire C drive to the state it was in the last backup on day 4, we need to restore the full backup from day 1 and then all of the differential backups from days 1, 2, 3 and 4. Lots of tapes involved, lots of tape swapping in the library, and a much more complicated process than if we'd just taken a full backup every night. But that's life in IT, right? It's always about making trade-offs and getting that right balance between cost and performance. Now let's talk about incremental backups. Incremental backups are similar to differentials, but slightly different. Let's take a look. Again, we start with a full backup on day 1, and we'll be performing incrementals on days 2, 3, 4 and 5. So on day 2, our incremental backup only backs up the data that has changed since the previous full backup. Then on day 3 we make some more changes, and when the job kicks in it only backs up data that's changed since the last full backup. And this is the crucial difference between incremental backups and differential backups. Incrementals back up everything that's changed since the last full backup, whereas differentials, they only back up changes since the last differential. And as we can see as we skip through the days, incremental backups back up more data on a daily basis than differential backups. but by doing this they have advantages over differentials. Let's say it's day 5 again and we've lost our C drive again. This time, because we've been doing incremental backups, we only need to restore the last full backup plus the latest incremental backup from day 4. No need this time for tapes from days 2 and 3. The changed data from days 2 and 3 is already captured on day 4's incremental, so less tapes and a faster restore. Kind of a nice middle ground between daily fulls and daily differentials. Time for one final type of backup, the synthetic backup, sometimes called a progressive backup. A bit of a newcomer to the backup world when compared to fulls, differentials and incrementals. But as you're about to find out, it's actually built using fulls and incrementals. And in fact, it works quite a lot like the recovery of our C drive that we just did with the full and incremental. It works like this. On day 1, we take a full backup. Always a full backup on day 1. Then, on days 2, 3, 4 and 5, we take incremental backups. Then instead of starting the cycle again with another full backup that trawls every block on our C drive and hauls all that data over the network again, what the system does is it takes an incremental backup and merges it with the last full backup that it's already got a copy of, and it creates a new image that's exactly what a full backup would look like if we'd actually gone out and taken a new full backup. And I'm sure that's as clear as mud, so we'll walk through it in a few pictures. What we're looking at on the slide now is our original full backup on the left that we acquired by reading our C drive and hauling it over the network to our backup device. Then on the right hand side we're showing our latest incremental backup that we've only just taken. Again, we got this from the host by backing it up and pulling it over the network to our backup device. So what we have is the very latest copy of all data that's changed since the original full backup. But as you can see, it's not an entire image. It's only the changes since the full backup occurred. And since we know that the missing blocks in our incremental backup shown on the right haven't changed since the full backup on the left, because if they had changed we'd have picked them up as part of this incremental, we know that in order to fill the gaps and create an image of what a full backup would look like, we simply take that most recent incremental as well as the data that's remained unchanged in that previous full. We've just changed the picture of that previous full now to have just the unchanged data, and we merge the two. And voila! What we have is a synthetic full backup image. And for all intents and purposes, it's exactly the same as if we'd taken a traditional full backup, only that it was a lot less work for the host and a lot less work for the network. Though, it has to be said, it's potentially quite a difficult task for our backup device to merge these two images. It requires lots of concurrent reading and writing. Now that we know all the major types of backups, let's talk about retention.